This is lesson 3. Nope. This is lesson 4.3, using isosceles and equilateral triangle theorems. So we're going to go over a whole bunch of vocabulary here about triangles. Let's jump in. Okay, so here are 6 terms associated with isosceles and equilateral triangles. We talked in the previous lesson about the classifications of triangles, and we know that isosceles is one type. And it's the type with 2 congruent sides. So when we show that, we just simply use a tick mark for the 2 sides that are congruent, like so. Now, those 2 sides have a special name for an isosceles triangle, and that is they are called the legs. All right, so this would be called, if we're using that same tick marked sides there, this would be called a leg, and this would be called a leg of the triangle, the 2 that are congruent. Then we have something called the vertex angle. Now, the vertex angle is the angle that's formed by those legs. So, again, if this side was congruent to this side, the vertex angle would be this one right here. Okay, because it's the angle that's created by those 2 sides. So this side and this side, if I deleted this other side here, where's the angle that's formed? Well, it's up here. Now, I want to make sure you understand that it doesn't mean that the vertex angle is always at the top. It's not always at the top. So let me show you something here. If I have that same triangle, or close anyways, and I said this side was congruent to this side, now those are my legs. So where is the vertex angle? Well, the vertex angle would be here. Okay, because it's the angle created by the 2 legs or congruent sides of the isosceles triangle. All right, so now base. The side of an isosceles triangle that is not one of the 2 legs is what we call the base. So for our same example here, if this side is congruent to this side, that makes this side the base. That makes that side the base. Again, if I went back to this triangle though, right here, which side is the base? Well, now this is the base of the isosceles triangle because it's the side that's not the congruent sides. So then we have the base angles. Well, I'll just tell you, the base angles are the ones that are not the vertex angle, right? So the 2 angles that are adjacent to the base or next to the base. So again, if we said this is our base, the 2 angles that are next to the base are these 2 here. And again, not the vertex angle. So we'll put this angle right here and this angle right here are our base angles, the angles that that base connects. All right, lastly, we have equilateral triangle. And again, we talked about this in the previous lesson. All 3 sides are congruent in an equilateral triangle, like so. Now we'll look at a couple of examples, just going through these vocab terms, and then we're going to talk about some theorems related to isosceles and equilateral triangles. Okay, so on this set of practice problems, I just want to make sure that you know which segment or side of the triangle is the base, because there's there's often trouble naming the base if a triangle looks like this. And this is going to be like something you need to think about this unit as well as several other chapters in this year. So keep this in mind. Just because this is at the bottom doesn't make it the base. And that is the issue that we have often. Like it's sitting on this side, so that must be the base of it, the base of the triangle. It is not. The base is the side that is not the legs, right? So in this case, since we know this is congruent to this, we know those are the legs, so this must be the base. So segment AC is the base. What's the base, for example, B? Well, if this side is congruent to this side, the base is segment EF. And again, if this and this are congruent, what is the base? Segment HI. So be careful with the base. All right, so here are our first 2 theorems related to isosceles and equilateral triangles. The first theorem says if two sides of a triangle are congruent, then the angles opposite them are congruent. So if two sides of a triangle are congruent, then the angles opposite them are also congruent. Let's talk about that word opposite. Okay. Here's the deal. If I was, and this is a way I've always explained opposite, and it helps some people. So if I was standing at this side of that triangle, let's say I was in a triangular shaped gym, and the coach of my team said, run to the opposite angle or opposite corner. Where would I run? Well, I would run over to there. Okay, so if I'm on this segment here, I'm running to the opposite angle that's down here. If I had been standing over here, the opposite angle would be over there, right? So that is the angles that are opposite them. So back to if two sides of a triangle are congruent, then the angles opposite them are congruent. That would mean that this angle is congruent to this angle. Okay? So the base angles. Remember, this would be the vertex angle. So that means the base angles are congruent. So if these two sides are congruent, the base angles are congruent. And then the converse, remember converses from chapter 1? The converse is also true. Taking this and bringing it over here. If two angles of a triangle are congruent, then the sides opposite them are congruent. So again, if I know that this angle down here is congruent to this angle down there, again, if I was standing in this corner and I ran to the opposite side, I would run over to here. If I was standing in this angle, I would run over to here. So these sides would be congruent. If two angles of one triangle are congruent, then the sides are congruent. Now, here is our first example of a corollary. A corollary is pretty much the same as a postulate or a theorem. It's just a theorem that is, it's like a theorem that's derived from an already proven theorem. So don't worry too much, or a related theorem. So if a triangle is equilateral, equilateral means all sides are congruent, then it is also equiangular, which means all of the angles will be congruent. Sorry, that tick mark's bad. Okay, and again, the converse of that is also true. If a triangle is equiangular, if all the angles are the same, then automatically we will know it is equilateral. So let's try some examples with that information. The first one says, find the measures of R, S, and T, angles R, S, and T. All right, well, here's angle R, here's angle S, here's angle T. I only know the side lengths. This side, RS, is 3 meters, and this side is 3 meters, and this side is 3 meters. Well, what you might be thinking is, well, I know all three sides are congruent because they're all 3 meters. And using that corollary on the previous screen, it says, if the sides are all congruent, if it's equilateral, then we will know that it's equiangular. So then I would know that all three angles are the same. Well, if all three angles of a triangle are the same, what must they each be? Well, let's remember the triangle sum theorem. We know that a triangle's degrees add up to 180, and there's 3 of them. So if we take 180 and divide it up by 3, well, we'll find out that each angle must be 60 degrees. So this is 60, this is 60, and this is 60. They are all congruent because it was equilateral, and 60 plus 60 plus 60 is 180. So that works out. Let's look at these 3 at the bottom. Find the missing value. So we're trying to find this question mark down here. Well, what do you think? Hopefully you're saying 70, right? The measure of angle M will be 70 degrees because we know these sides are congruent. And if those sides are congruent, then the angles that are opposite them are also going to be congruent. And so they are both 70. Same thing happens in the next one, right? We know these 2 angles are congruent, so I can use that information to help me find the missing side. If the angles are congruent, then the sides opposite them are also congruent, which means that this side will be 18. And the last one, same idea. Takes a little more work here, but we know these base angles are congruent, and if those base angles are congruent, then the sides that are opposite them are also congruent, which means we can set up an equation. (4x plus 3 equals 15). And we can subtract 3, 4x equals 12, and divide by 4. So x equals 3, and that is the missing value, right? The variable x. So we just needed to find x equals 3, and we're good to go. Again, 4 times 3 is 12, plus 3 is 15. They both need to be 15. Okay, so take a minute and try these two examples based on the information you were just given and see what you can figure out. Find the value of x. Okay, so a couple of problems completed here. Hopefully you found out x equals 4 and x equals 12. Just a really quick run through. Guys, we had the angles congruent down here. So we know the sides across from them, opposite them, are congruent. So we set these two things equal. The 20 was not needed in this question. If you thought you needed to use it, or you wondered what it was for, or you did use it, it shouldn't have been used. So this is how to solve this problem. For f over here, there's a couple ways you could do this problem. First of all, we knew that all three sides were congruent because they're all 10. So I put my tick marks in, which means that the angles opposite them all, or all the angles, are congruent. My first thought was, oh, well, then I know they're all 5x. So I wrote 5x plus 5x plus 5x equals 180, and I solved and got x equals 12. The other thing you might have realized is on a previous example, we realized that equilateral triangles will always have 60-degree angles because if they're all congruent, they're all 60. So I just set 5x, that angle right there, equal to 60, and solved and also got x equals 12 that way. Either one of those methods will work. All right, let me know if you have questions on any of our isosceles or equilateral triangle theorems.